Hi boys and girls, today we're going to be looking at doing something completely different. We're going to be working with shapes today. We're going to be looking at polygons and we're going to see if we can identify regular and irregular polygons. So first of all, we're just going to go over some of the revision from year 4, just to make sure you're really clear on what a polygon is and what the terms regular and irregular mean. Well, a polygon is a flat shape, all right? It's two-dimensional and it will have straight sides, no curves at all, okay? And it has to be a complete shape as well. I'll show you what an example of what I mean in a moment, okay? So here we've got some examples over on this side here, which are going to look at some irregular and irregular shapes, okay? If we just go on to the next slide, we can see that this does have straight sides. It is a polygon. This isn't a polygon because you can see there it's got one of the sides there is curved, and this isn't a polygon because that part of the shape there is not closed. All right. So if you're interested in etymology and the origin of words, you can see here that polygon is a Greek word, poly meaning many and gon meaning angle. So there you go. Hopefully, for those of you out there interested in that sort of thing, that'll be something that will be nice for you to know. All right. So types of polygons. So you can have regular and you can have irregular. And what defines the two is that a regular polygon will have all sides the same length and all angles are equal, okay? So these are both pentagons, all right? You can see there that we have 1, 2, 3, 4, 5 sides, 1, 2, 3, 4, 5 sides. But when you look at that shape, you can see that the sides aren't all the same in the irregular shape. Okay, they're not the same length, and the angles aren't all equal as well. All right, so that is the definition. Now, how can you spot some of those differences? Well, the best way to do it is with an angle measurer if you're not sure. But if you, in the absence of an angle measurer, you could try and use the edge of your ruler just to see if it's a right angle or not. Or sometimes you can make a pretty good kind of estimate just by looking at the shape. And actually, you will know, those of you that can remember your work from year 4, that is what we would consider the sort of pentagon that you would see, a correct mathematical example of a pentagon. All right, so the thing to remember here is angles equal and sides equal, okay? So let's move on. We're going to have a little go now at trying to sort the shapes into regular and irregular polygons. So you can just have I suppose you could either do maybe a little sort of table like this, and you could perhaps give them letters A, B, C, D, E, F, G, and see if you can look at those shapes and you can see whether or not they are regular or irregular. So you can pause the video now, have a go at that, and then we'll talk about the answers. Okay, good luck. Okay, so hopefully you've had a chance to have a look at sorting some of these shapes. So we'll start off with shape A. Well, if we look at that, we can see that all the sides aren't equal. All the angles are equal, but the length of the sides changes with the rectangle there, okay? So we will put shape A as an irregular shape. Okay, moving on to shape B, we'll count the sides there. We've got 1, 2, 3, 4, 5, 6. Six-sided shape makes it a hexagon, and that is a regular hexagon. All the sides are the same length, and you can see that the interior angles there are all equal. So the hexagon can go over here with on the regular side. Shape C, that is a 5-sided shape. All right, that is a pentagon, but as we can see, not all the sides are the same length. All right, so shape C is going to go here. All right, so we don't have to worry about the angles. We can see that all those sides aren't the same. Moving over to shape D, we've got 1, 2, 3, 4, 5. So again, it's another irregular pentagon. So I'm going to put that one over here. Looks very different to the pentagon that we were just looking at there. Shape E, that's an equilateral triangle, okay? all the sides are the same length, and all of the interior angles are equal as well. So that's a regular shape. Okay, have a little think, maybe for a little bit of a bonus point. If angles in a triangle add up to 180 and all these angles are equal, see if you can find out what each one of those angles is equal to. Have a go at that, and we'll find out the answer at the end of the video. So E's going to go there. F, that's a parallelogram, okay? So if you can see, opposite sides in a parallelogram run parallel to one another. So those opposite sides there are parallel, and these opposite sides here are parallel. That's one of the things that makes it such an interesting shape. But we can see that not all of the sides are the same length, so it is going to be an irregular polygon. And our last shape there, that's a square. All right, it's just put in a different orientation there. It's just been tipped on this vertex here. All right, squares. What makes them special is that they have all sides the same length and all the angles are 90 degrees. So we can put that over here with our regular polygons. All right, let's go back to this question here that we were just looking at. Yeah, when we're talking about shape E, if all of the angles in a triangle add up to 180 degrees and there are 3 equal angles there, then each one of those angles is 60 degrees. All right, so well done if you did that, if you did 180 divided by 3. Okay, all right, let's move on to, oh no, that is actually it. All right, so hopefully that will help you now with some of the work that you're going to be doing today. All right, don't forget all of the rules that we have to follow here when we're deciding whether or not a shape is a polygon or not. All right, it's got to have sides the same length, angles the same size, no curves whatsoever. All right, and no gaps. Okay, nothing missing. All right, so good luck with that today, boys and girls, and I will speak to you later in the week. Okay, bye.